First thing is, elements are arranged in increasing order according to atomic weight, and every 8 element will have the same property like first element. Elements with increasing order according to their atomic weight. But if the elements are arranged in horizontal rows, second period, which and all orbitals will be there? 2s and 2p. Okay, this is a very short period containing only 8 elements. Hello everyone, I am Venu Prasad, Department of Chemistry, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. Today I am going to do Unit 3, Classification of Elements and Periodicity in Properties. Okay, now let us study today Dobner's Law of Triads, Newland's Law of Octaves, Mendeleev's Classification of Elements, Modern Periodic Law, Electronic Configuration of some Elements, and Classification of Periodic Table into blocks. In periodic tables, some blocks are there like S block, P block and D block. So we have classifications. Okay. Now let us study Dobner's law of triads. Okay. Dobner's law of triads, according to him, there are 3 chemically related elements. There are 3 chemical related elements and they were grouped. Okay. The atomic weight of the middle element, was the mean of atomic weight of other 2 elements. Atomic weight of middle element was the atomic weight of other 2 elements. Okay. Also the properties of middle element, were in the between of those 2 members. Means here now let us take today lithium. Its atomic weight is 7. Okay. Atomic number is how much? Its atomic number is 3 and atomic weight is 7. And atomic number of sodium is 11 but its atomic weight is 23. Potassium. Its potassium's atomic number is 19 but its atomic weight is 39. Calcium, its atomic weight is 40, atomic number is 20. Strontium, its atomic weight is 88 and barium's atomic weight is 137. And chlorine, atomic number is 17, atomic weight is 35.5. And bromine, its atomic weight is 80 and iodine, its atomic weight is 127. So here they have said that, in Dobner said that just 3 chemical elements were related and they were grouped. 3 chemical elements they have taken and they are grouped. Okay. Middle element will have the same property. They have said that atomic weight of middle element was the mean of atomic weight of other 2 elements. Atomic weight of middle element was the mean of atomic weight of other 2 elements. Next, also the properties of middle element. Properties of middle element were in between of those 2 members. Properties of middle element will have the same property like other 2 elements. So this was the suggestion by Dobner's. Okay. Next thing is Newland law of octaves. Here the elements were arranged in increasing order. Elements were arranged in increasing order according to their which one? Atomic weight. And they 8 element will have the same physical and chemical property as that of first element. They will have 8 element will have the same property like first element, they have said. And this was similar to every 8 musical note. Okay. And this has got repetition of first musical scale, they have said. First we have to think that first thing is, okay, here just elements are arranged in increasing order. First note we have to maintain that. Okay. First thing is elements are arranged in increasing order according to atomic weight and every 8 element will have the same property like first element. Okay. Every 8 element will have the same property like first element. So now let us see here. Lithium. Lithium's atomic weight is 7. Beryllium is 9. Boron is 11. Carbon is 12. Nitrogen is 14. Oxygen is 16. And fluorine is 19. So they have arranged the elements according to their atomic weight in the order of increasing order. Okay. Next thing is sodium. Sodium's atomic weight is 23. Magnesium is 24. Aluminium is 27. And silicon is 29. Phosphorus is 31 and sulfur is 32 and chlorine is 35.5. Okay. Here you see potassium. Potassium's atomic weight is 39 and calcium's atomic weight is 40. Okay, these are the laws of Newland. Just he said that elements are arranged in increasing order according to their atomic weight, but every 8 elements will have the same property like first element. He has said that much. Okay, next thing is Mendeleev's classification of elements. In Mendeleev's classification of element, Mendeleev arranged the elements in increasing order. Elements in increasing order according to their atomic weight. According to their atomic weight in horizontal rows. They are called as periods. Okay. Next thing is vertical columns. They are called as vertical columns are called as groups. So that the elements with similar properties are occupied the same group. Elements with similar properties are occupied with same group. We should know that. Okay. Just they have said elements with increasing order according to their atomic weight. But if the elements are arranged in horizontal rows, okay. If elements are arranged in horizontal rows, then they are called as which one? Called as periods. Okay. Next, vertical columns. They are called as rows. So that elements with same properties, elements which show same properties, they are said as same group. They are occupied as same group. Okay. Just much. This was explanation of Mendeleev's. Okay. Next thing, Mendeleev's periodic law, they have said that the properties of elements are periodic functions. Properties of elements are periodic functions of their atomic weights. We should know this. Okay. The properties of elements are the periodic function of their atomic weight. Why they have said like that? Because the elements which show similar properties, they have arranged in same group. They are occupied in same group. Okay. And elements with horizontal rows, they are called as periods. Horizontal rows are called as periods. Vertical columns are called as groups. Okay. Next thing is merits. Merits of Mendeleev's periodic law. Okay. The study of elements was made easy as the elements with similar property. Study has been made easy and elements with similar properties are made with same group. They are occupied in a same group. Next thing is Mendeleev had left some vacant spaces for the yet to be discovered element. He had kept some vacant spaces because some discovery was going on at that time. So he had kept one vacant space in the periodic table. Next, Mendeleev left space for which and all elements he left? For gallium, named as eco-aluminium, and germanium, named it as eco-silicon. He had left for the two elements, that is called gallium as well as germanium. And the elements were discovered later and properties predicted by Mendeleev were to be correct. Elements were discovered by Mendeleev and it showed some physical properties as well as some chemical properties, and Mendeleev discovered that. Okay. Just what was the merits of Mendeleev's periodic law? The elements were arranged in increasing order according to their atomic weight. But elements which show same properties are kept in a same group. That was the first thing that made very easy for us to study all the properties of some elements. And he had left some spaces in periodic table for the discovery of some element. Which are the elements? First thing is gallium, second thing is germanium, and it was discovered by Mendeleev and it showed some physical properties. It was a correct explanation and it was made correct. Okay. Next thing is modern periodic law. In modern periodic law in 1913, Henry Moseley proved an experiment that the atomic number is the most fundamental property and not atomic weight. In 1913, Henry Moseley proved the experiment that just atomic number is most a fundamental property but not a atomic weight. The physical and chemical properties are the periodic functions of their atomic number. Means physical properties and chemical properties all depends upon the which one? Atomic numbers. Okay. Next thing is the electronic configuration of some elements. What do you mean by electronic configuration of some elements? Here, the distribution of electrons in an orbitals. Distribution of electrons in an orbitals of an atom is called electronic configuration. Now let us write some examples for the electronic configuration. Okay. Now let us take carbon. Carbon's atomic number is how much? 6. Here we are writing the electronic configuration on the basis of atomic number. Now let us study here. Carbon, its atomic number is how much? 6. So how I have to write? 1s2, 2s2, 2p2. Okay. Next thing is oxygen. Its atomic number is 8. How we have to write? 1s2, 2s2, 2p4. Okay. Now let us study some big elements. Okay. Sodium. What is the atomic number of sodium? Atomic number of sodium is 11. 1s2, 2s2, 2p6, 3s1. So it is the electronic configuration of sodium. Now let us write for D block elements. Okay. Scandium. Its atomic number is 21. How we have to write? 1s2, 2s2, 2p6, 3s2, 3p6, 3d and 4s. Okay. Here how much we have got? 2, 4, 10, 12, 18 we have got. First we have to fill an electron to s orbital. Okay. And 1 electron to d orbital. Why? Because 4s orbitals is in the lower energy level. So I have written like this. Okay. So we can write this as argon. 3d1, 4s2 we can write. Okay. This is the electronic configuration of some elements. Okay. Now let us write another one. It's copper. Copper's atomic number is how much? 29. Here, this is one exceptional configuration. Okay. Here, we have to fill electrons to s orbital. After that, we have to fill it to d orbital. But in case of copper, we have to fill 1 electron to s orbital and 10 electron to 3d orbital. But actual configuration is like this. Okay. This is a right configuration. But if we write like this, this is wrong actually, because to attain stability we are preferring this configuration but not this one. This is wrong configuration. If you write like this, this is a wrong. Actually copper will not attain stability at all. So I prefer this configuration. Okay. These are the some electronic configuration of some elements. Okay. Next thing is the classification of elements in periodic table. Okay. How much elements are present? 118 elements are present in periodic table and it has been discovered. Correct, right? However, only 114 has been named by IUPAC. Out of 118, 114 has been named according to IUPAC nomenclature. Okay. Here classification into period. Now let us study. Okay. The periodic table is classified into 7 period. Okay. The first period, it is a very short period and it is a nearer to the nucleus. Okay. First period is very nearer to the nucleus, and which orbitals will be there? It is 1s orbital will be there in a first period. Okay. So it is a very short period containing only hydrogen and helium. Only 2 elements will be there in first period. Which and all? Hydrogen and helium. Its atomic number is, hydrogen's atomic number is 1, helium's atomic number is 2. Okay. Next thing is second period. In second period, which and all orbitals will be there? 2s and 2p. Okay. This is a very short period containing only 8 elements. Containing only 8 elements from lithium to neon. From lithium to neon. It contains only 8 elements in second period. Okay. Next, if we are going to third period, it has got 2 orbitals, which and all? 3s and 3p orbitals. This is a very short period. Again, it contains how much electron elements? 8 elements from sodium to argon. Sodium to argon, it contains 8 elements. So n is equal to 3. Which orbitals it has got? It has got 3s and 3p orbitals. Okay. Next thing is fourth period. This is a very long period containing 18 elements, and from potassium to krypton. From potassium to krypton, it has got 18 elements, and this is called as 3D transition series. 3D transition series means they are called as D block elements. Here you see 4s and 3D elements are there. So we can say that it is a D block elements. Okay. So next thing is fifth period. In fifth period, it has got 5s, 4D and 5p. 5s, 4D and 5p. These are called as long period. This is also called as long period. Why? Because it also contains 18 elements. 18 elements from rubidium to xenon. From rubidium to xenon, then it is considered as fifth period. It has got which and all orbitals? 5s, 4d and 5p. Okay, and this is called as 4D transition series. This is also 4D transition series when n is equal to 5 and it will have 18 elements. We should know this. Okay. Fourth and fifth one will have 18 elements and they are called as 3D and 4D series of transition elements. Okay. Next thing is sixth period. In sixth period, which and all orbitals are present? 6s, 4f, 5d and 6p. And this is a very long period. How much electrons is there? How much elements? It has got 32 elements from cesium to radon. From cesium to radon, it has got 32 elements in this periodic table. Okay. Filling up of 4f orbitals begins. Here filling up of 4f orbital begins from which one? Cerium and ends up with lutetium. And this is also called as lanthanoid series. So we can say that lanthanoids means they are called as inner transition elements. Also we can say that it is a F block elements. Okay. Next thing is seventh period. In seventh period, these elements, which and all orbitals will be there? 7s, 5f and 60 orbitals will be there. This is an incomplete period containing most of the man-made radioactive elements. This periodic seventh period contains, it is a radioactive elements. Okay. So we can say these elements in bottom of the periodic table. Okay. So this is also called as incomplete period containing most of the man-made radioactive elements. These elements beginning with francium, filling up of 5f orbitals with thorium and ends up with lawrencium, and they are also called as actinoids. Actinoids means the atomic number greater than 92. They are called as inner transuranic elements, and they are also called as F block elements or inner transition elements. Why they are called as inner transition elements? Because electrons are added to anti-penultimate shell. Okay. Next thing is S block elements. Now let us study S block elements. Okay. Here the S block elements means its general electronic configuration is NS1 to 2. Okay. Here the last electrons enters the S subshell of their outermost energy level. S subshell of outermost energy level, and they are called as S block elements. Okay. The elements of group 1, they are called as alkali metals, and group 2 they are called as alkaline earth metals, and they belong to this group. Alkali metals and alkaline earth metals, they are called as S block elements. Now let us study the characteristics. Okay. They are called as soft metals and they have got low ionization enthalpy, and its oxidation is +1 for alkali metals and +2 for alkaline earth metals. Metallic character and reactivity increases as we move down the group. Metallic character and reactivity increases as we move down the group, and predominantly except lithium and beryllium, they are also called as covalent compounds. Lithium and beryllium compounds are covalent compounds. We should know that metallic character and reactivity increases as we move down the group. Okay, we should know this. Okay, next thing is P block elements. In P block elements, what is the electronic configuration? NS2, NP, 1, 2, 6. We should know that. It's very important. General electronic configuration of P block means we should know that. Okay, here the electrons in which last electrons enters into the which subshell? P subshell of their outermost energy level, and they are called as P block elements. The elements of group 13 to 18, they are called as P block elements. Characteristics, if you are studying, means they include both metals and non-metals. The metallic character increases as we move down the group. That is very important. We should know that. And for non-metallic character increases from left to right, they have said. Left to right means from left of the periodic table to right of the periodic table, non-metallic character increases. Next thing is, most of the elements shows variable oxidation state. Why they show variable oxidation state? Because the elements are unpaired electrons. The elements will have most number of unpaired electrons. Then only that elements will show variable oxidation state. Okay. Next thing is, elements which is present in group 18. The elements which is present in group 18, they are called as noble gases. Okay. In next session, we will be studying about D block elements and its characteristics, and these elements are considered as transition elements. Why these elements are considered as transition elements? Because electrons are added to penultimate D subshell. Okay. So these elements are also called as transition elements. In next session, we will be studying this. Thank you.